Sorry for the interference. I was just thinking of getting it. Now, so there's the first method. So here is the first method. The second method is Hoffman's bromomide reaction. Hoffman bromomide reaction. The Hoffman bromomide reaction is what is known as RCONH2. You take an amide. Okay, I will take a C6H5. I will remove the R. R is not C6H5 CONH2. This is called benzamide. Benzamide. This is treated with potassium hydroxide and bromine. Bromine and potassium hydroxide. The product what you get is RNH2, C6H5NH2. Look at that. The CO group has gone, plus potassium bromide, plus potassium carbonate, K2CO3. Plus water. So this is what is called Hoffman's bromomide reaction. You can see you can reduce the number of carbons in a molecule like this. This carbon is lost as carbon dioxide. So what you're getting is C6H5NH2. So this is the example for a bromomide reaction. Okay. Any other method by which you can make yes, you can make amines from the same compound. You do a reduction with lithium aluminum hydride, LiAlH4, giving you see here CH2 NH2. CH2 NH2. One second. Somebody has passed a message. Yeah. So this is C6H5CH2 and H2. Here, lithium aluminum hydride H minus is attacked here. H minus is attacked here and is formed O C6H5COH H, and then again the second H minus attacks and removes this hydrogen. 2 hydrogen is added here. Okay, so that is another method of making amines. Now let us look at the reactions of amines. Let me see whether any other method is there. Okay, that is there. I think that is quite enough for the preparation of amines. Now let us look at the properties. The first property is basicity of amines. Basicity of amines. Now, amines are basic compounds. For example, C2H5NH2. C2H5NH2. What is a base? A base is a substance which is ready to donate a pair of electrons. So, if you react this with HCl, the lone pair of electron will obstruct this proton and will form R. Oh, sorry, I use C2H5. C2H5 N H3 plus, plus Cl minus. Okay, so this is an ammonium chloride salt, acid base reaction, right? If you take now, so this is a primary amine. This is a primary amine. Now let us compare with this with the secondary amine, C2H5 and H C2H5. Now will the availability, see the availability of electron here. Availability of electron here is a measure of availability of electron. Availability of electron on the nitrogen. On the nitrogen is a measure of basicity. Is a measure of basicity. MEASURE. Measure of basicity. Meaning the more it is available, the more it is basic. The more it is available, the more it is basic. What is the meaning of that? Now look here, I got C2H5 N H and H. I have C2H5 and C2H5 and H. And then C2H5 and C2H5 and C2H5. Tell me which one will be more basic? What is the order of basicity? The order of basicity you can decide by the availability of nitrogen here, electrons here. The more concentration of electron, the more basic it will be. Now look here, inductive effect. What inductive effect will do? Look here. It is concentrating the electron more from here. It is donating. Plus psi effect. Here also. Here also. Now compare this and this. Now you can compare this and this. Here you have two alkyl groups. It further increases electron density. So this is more basic. More inductive effect by two C2H5 groups. Still more inductive effect. From all the side there is three alkyl groups will increase. So more basic. More basic. Here that's basic. Now what about this compound? NH2. You cannot, you cannot, you cannot resonate this into this. Okay? You cannot resonate this into this, so you have comparable basicity here. But the basicity is decreasing actually. You can see here. See this. So if you have a double bond, the electron density is lost. So this is less basic. Now what about this molecule? Aromatic amine. Now you know this is the resonance structure. That means the lone pair of electron is participating in the resonance into the benzene ring. Right? So it goes here and it goes here. So the electron density, it is reducing the electron density, therefore less basic. So aniline is less basic than triethylamine. Aniline, this is aniline. Aniline is less basic than triethylamine. Triethylamine. Okay, so this is how you find the basicity. So what you have to do, if you are asked to find the basicity and compare the basicity, you try to draw the resonance structure and see whether the electron density is concentrating or spreading from nitrogen. If it is concentrating, it is more basic. Okay. Now, so that is about basicity of the amines. Okay. And you know the basicity, there is something called Kb. Acidity and basicity, you know. Acidity is shown by Kb, Ka, sorry. Ka is acidity and Kb is basicity. Now what is Kb? It is an equilibrium constant. Kb is equilibrium constant for what reaction? What reaction? I will take, say for example, I take this compound, C2H5NH2. So what is basicity? Its ability to react with water to form C2H5 NH3 plus and OH minus. So the ability to release more amount of OH minus is what is basicity. The ability to release more amount of OH minus. Okay. So what is Kb? Kb equals concentration of C2H5 NH3 plus into concentration of OH minus divided by concentration of C2H5NH2 undissociated. Okay. Now, so when this is more the value, more basic it is. Higher the value, higher Kb, more basic. If we take the negative logarithm of this, log Kb, you call it as pKb. pKb value. Since it is negative, lower the pKb, lower the pKb value. Oh, sorry, pKb, higher the basicity. Higher the basicity. There. Okay. Now, so that is now. Can you continue? Can you continue about 15 minutes more after the once this is over? Do you have a class at 8:45, 9:45? No. നിങ്ങൾക്ക് ക്ലാസ് ഉണ്ടാവും ഇല്ല okay ശരി so we'll continue about 15 minutes more once this is disconnected okay so this is about basicity so higher value now I will just give you a few examples methylamine let us see how it is working methylamine methylamine is having a value 3.36 pKb 3.36 pKb ethylamine 3.25 ethyl is 3.25 which is smaller value 3.25 it is more basic okay diethylamine ethylamine 3.02 okay diethylamine is 3.02 it is still smaller now here there is a difference triethylamine there is a difference triethylamine it is 3.2 okay now here this difference is due to a factor known as solvation effect actually you expect this to be higher than to be more basic but here you can see this one is low that is due to a exception because of the solvation effect we expect triethylamine to be more basic than diethylamine but it is not the case that is because of solvation effect okay now let us look at your aniline NH2 the basicity value is 9.37 see that 9.37 very high value so far less basic now look at another compound aromatic compound nitrogen here this is also basic but very less basic this is called pyridine we have seen this before in aromaticity it is 88.75 it is more basic than aniline so this is the basicity and basicity and of different amines okay now I will just stop this and close this and we will rejoin again okay just 10-15 minutes more we'll take rejoin I'll just Stop this.